Hi, I'm Tim Zacharias with Cougar USA and your host of Building Value. We are on location today in Orlando, Florida at the Orange County Convention Center for the 2020 AHR Expo, and I'm joined by Director with Cadeo, Sarah Widder. Thank you for joining me.
My pleasure. Thanks for having me, Tim.
Yeah. And she's definitely the smartest guest that I've had on the show. But it is not even close. So today we're going to be talking about Sarah's background and her work recently with NEEA, specifically about the PEI and Energy Ratings that have just gone into effect. We're also going to be talking about her research on pump lifecycle cost and pump load profiles, some really interesting research that they've done up in the Pacific Northwest. On Building Value, we go behind the scenes at some of the most iconic buildings in Texas to showcase the incredible people that design, build, and maintain them and their impact on the community. It's interesting that it's taken this long for regulation to apply to pumps. I mean, the electric motor is probably the number one machine in the world, and a pump can't be far behind.
Right.
Right.
Yeah.
So, I mean, what is the PEI and now HI's ER, the energy rating? What is that regulation, and how is it going to be? I mean, I guess it was 4 or 5 days now that it's in effect.
In effect, how's it changing the market?
Yeah.
You know, it's already had a big impact. So it was a long time coming. Pumps were always under DOE's authority to regulate ever since 1975, when DOE first got authority from Congress under EPCA, the Environmental Policy and Conservation Act. But they had a kind of a long list of equipment that they were supposed to get through first. And so they were just kind of busy with that, and different administrations had different emphasis on appliance standards. And some of that was like the anti-regulation stuff that we saw a lot in the 80s and 90s, and even under Bush, not a lot of standards happened. And even under some more progressive presidents, appliance standards are not sexy, so you're not going to be like, oh, yeah, environmental, I'm going to regulate this toaster. So it just never kind of got overlooked. Obama was really the first one to really push appliance standards as part of his climate action plan, because they can have huge impacts on carbon and energy savings. And so he was the one that really pushed DOE to exercise their authority over products that weren't regulated or mandated to be regulated. So that's where pumps came from. The industry association worked with DOE from the starting in 2010, 2012. And so it's a long time, even just working through the regulation process, working with DOE to collect all the data necessary to do a rigorous analysis and figure out what levels were going to be economically viable, but also kind of save energy and the best on behalf of everyone.
Right.
Technically justified. They entered this negotiation process with manufacturers and kind of agreed on the level and the test procedure, and published that in 2016. So, and then DOE usually has a couple years lag time where they allow manufacturers to get ready and get their products certified. Just came into effect on Monday. So now we are going to be seeing PEI on all pumps. All pumps are going to have a PEI less than or equal to 1.
Right.
That's the standard. And that'll mean that about 25% of products that used to be on the market either had to be redesigned or discontinued.
Right.
And I think so that's already had an effect on the market. So we've seen the market average efficiency go up due to manufacturers changing those product lines, and that was expected based on the regulation. But I think the other thing PEI and Energy Rating, HI's Energy Rating label has done is really raise awareness about efficiency in the pump industry again. And so manufacturers didn't just, meet the standard when they went to redesign their product lines. They really went above the standard.
Right.
And now the industry is looking to these metrics, and utilities and other energy efficiency organizations are pushing for higher and higher levels. And so I think we'll continue to see this kind of drive pump efficiency and end users asking for more efficient equipment, which I think is a good thing.
It is, and I think the pumps have been kind of the stepchild for a long time. When
sure.
you're looking at like the potential energy savings in a building, people are going to look at the big things, the chillers, the lights, the cooling towers, whatever it is. And so for pumps to now be a focus there's huge potential there.
Yeah, for sure. Yeah, they were often overlooked, but they're such low-hanging fruit. I mean, there's a lot you can do there.
I wanted to ask you about the Cadeo Group and kind of your relationship with NEEA and the Hydraulic Institute and the work you've been doing there.
Yeah, so after I was at PNNL, I left right around the turn of the administration to join Cadeo Group, and it's a small consulting firm. We work really nationally, but a lot of my work is focused in the Pacific Northwest. It's where a lot of the energy efficiency action is, especially in this climate. And so it's a fun place to be because that's where the ideas and the progress is happening. We work with the Northwest Energy Efficiency Alliance, and they are an organization that works on behalf of 140 organizations in the Pacific Northwest. They're kind of unique because they are required to be funded by utilities who are required to acquire conservation as part of their generating plan. And that's a really unique situation that allows them to do a lot of good work and have a lot of impact in the Pacific Northwest and nationally.
Right.
So we work with them on a number of programs. One of them is this extended motor products program that covers pumps. Also, hopefully will cover fans and compressors, all motor-driven equipment. And the idea is to work with distributors and the market actors that really have the most influence on the equipment that's being installed to promote efficiency in the market, promote selection and stocking and purchasing of more efficient pump equipment to hopefully drive down energy use.
That's awesome. And I mean, the whole goal with this, right, is to obviously you're wanting to reduce the energy consumption, but it's also to prevent having to build future generation, correct?
Yeah, totally. That's the mission for NEEA and for the utilities that are funding NEEA. It's required under the Northwest Power and Conservation Act that conservation is considered on par with new generation. And so since that act went into effect and utilities have, in essence been required to acquire conservation, we haven't built a new generating facility in 30 years.
That's
but
incredible.
We've grown a lot.
Yeah, it's really incredible. And, I think the conservation, especially with, these type of energy upgrades are going to be easier than building new generation, right?
Definitely. They're more cost effective.
Yeah.
And I think the utilities have to recognize that. Yeah.
That's awesome. And so what about the work that you've been doing with Hydraulic Institute?
Oh, yes, and Hydraulic Institute. So through our work with NEEA and my work with DOE on the pumps regulation, I got to know the Hydraulic Institute. They are a great and really progressive organization. They've really been good allies for NEEA in developing this efficiency program. They've developed the energy rating label that's based on DOE's PEI metric.
Right.
Really takes PEI, which is a very technical metric, and tries to make it more customer facing.
Sure.
That's really what their intent was, and I think it was successful. Through working with them kind of alongside NEEA in promoting efficiency, we've also started working with them directly to help encourage other programs like NEEA's nationally. So other utilities that are looking for new commercial and industrial efficiency opportunities have the resources that they need to develop a program, and Hydraulic Institute can help them, have the analysis and best available data to have a program that will work and can point to these other examples.
And it's going to use the energy rating as a simple way to implement that program, correct?
Yeah, correct. So it's going to be based on HI's label, and then they have a publicly available database that's based on these third-party validated test data that utilities can use essentially as their qualified products list, so they can leverage HI's resources to develop a program that they can run midstream. Yeah.
That's great. And so, this will make it a lot easier for the energy providers to have these incentive programs without having to do all the research themselves, right?
Yeah, exactly. It's just a way of sharing information and making it easier for people to take advantage of this opportunity, both for utilities, and then a lot of what we've heard and why we're encouraging midstream is it makes it easier to get that efficiency out there into the marketplace as well. Makes it easier for distributors to implement, makes it easier for end users to access the rebates, and kind of everybody wins.
Yeah, No, I think that's awesome. So let's talk about that database.
Sure.
Because you played a big part in that.
Yeah.
Right? So what is all the pump audit data that you collected, and how are y'all using that?
Oh, yeah. So there's two databases.
Okay.
I'll tell you about both of them.
Awesome.
One of them is HI's database, which I did help them develop, but they really did it on their own. And that has information about every certified pump model and the tested
Right.
information. And that's publicly available. You can look it up. And that is tells you about all the pumps that have been rated under the AHR Energy Rating Program. There's another database that provides even more useful information that was generated under this program. So as part of developing these incentive programs, we worked with NEEA to do a big research project and better understand pump energy use and energy consumption in the field to make sure that when we're estimating energy savings for a pump, that kilowatt hour value is as reliable as a power plant, because that's what we're using it to replace. So we did a research project to better understand how pumps are using energy in the field, and we collected data on over 400 pumps from a range of sizes and applications, and we have that data available also, which I think helps validate our energy savings measures, but can be used in a lot of other ways. So we have data on the kind of nameplate horsepower, BEP, kind of all of the static characteristic information of the pump. And then for each of those pumps, we have a full hourly profile of their head flow and input power information, so that you can see where each pump in each application was operating throughout a typical year.
Getting good load profiles in all kinds of different applications.
Exactly.
Because this was over all kinds of different, it wasn't just all in closed loop or booster pump applications, right? It was.
Right. Yeah, so we look at hydronic heating, domestic hot water. We've got municipal and agricultural applications, some industrial applications, mostly boiler feed water and chiller applications. And then we do have a couple other ones. And that's most of it. And booster pumps, yeah.
And you were showing us some of the analytics that you've been able to run against this database, and some of I think the results y'all expected, right? And then some maybe a little bit unexpected. But I thought one of the really interesting things that you showed us was how the majority of the time these pumps are running to the left or at lower flow rates than the BEP, the best efficiency point.
Yeah.
So what is that? What do you take away from that?
That is a good question. And I think, that's one that was both surprising and unsurprising. I think a lot of us expected the pumps to operate to the left of BEP, especially for commercial HVAC. You have a variable load. But like if you look at AHRI 210, 240, which is a profile that AHRI has developed for commercial HVAC loads, or just some of the other loads out there, they assume a lot more of the load is happening at 50 and 75%, like kind of right in the middle, a little bit on the tail end and a little bit up at peak.
A nice bell curve.
Yep, nice bell curve. So that's what those look at. And what we saw in our research was that the majority of the time is spent below 25% of BEP. That really, there's a lot of time spent at those really low flow rates. And that could be due to a number of reasons. I think my takeaway from that is that a lot of pumps are oversized, which we know, that's not necessarily said as a negative. There's a reality there that we want to make sure that pump can do the job and we don't have to replace it. So being a little bit safe on pump sizing maybe is a reality that we don't want to go up against.
Right. Yeah. Nobody wants to come up short.
Right. But it does mean that we really want to focus on the efficiency and energy consumption at those low flow rates. I think that's really the takeaway for me. That's how we achieve efficiency. You could pick a pump with an excellent BEP efficiency, and that's great, but it's not going to save energy. It's never going to operate there.
Yep.
And so really focusing on how we select our pumps, but also importantly control our pumps down at those low flow rates where they're spending the majority of their operating hours is really what's going to drive energy savings. And a lot of manufacturers are coming out with these integrated pump control solutions that I think are really targeted at that problem. At trying to figure out how to control pumps to use the least amount of energy, where they're operating, which might be 25% flow.
Yep. Yeah, and it's interesting that you're using that the 25% as kind of across the board. What we've seen when we've done our own flow audits, and then we run the numbers using the fixture units and Hunter's curve, and we come up with about 15%.
Yeah.
As 15% of what Hunter's curve says the max flow rate is where the pumps are going to be operating. So that's usually where we target to make our pump selections. And, and I'm specifically talking about domestic boosting applications right now. But, I mean, so we target that for our pump selection. And then we say, okay, how many pumps do we have to add to cover the full potential load? And so that way we can use those cascading pump controls like you're talking about from Grundfos and address that lower end operation. So, I mean, it's just cool that your data in a totally different part of the country with all these different pump applications shows similar data. So that's very cool. Yeah. So is that, is there anything else that is going to be part of this regulation that may address, BEP based on design versus what's actually happening in the real world? We kind of talked about that a little bit yesterday. I mean, or is there any research that you could do to kind of look at what was the design versus what's actually happening in real life?
Yeah, I think there's definitely some additional research that we want to do. I think, one thing we didn't get to look at as much as I would have liked in the research is we collected characteristics on the pump, so we know what the pump BEP is, and we collected characteristics on how the pump was operating, so we know how it was operating. The thing we didn't collect information on, just due to logistics, was where that pump was selected. What was the design point or the duty point? And I think the relationship of where it's actually operating, the duty point, and BEP is really where, you really need to know.
See all three.
Yeah, you need to see all three.
Sure. I mean, I guess for this study, I mean, it's hopefully you could assume that the design duty point was close to where the actual BEP of the pump is, right?
Yeah, you could.
You'd hope.
Right? You'd hope. Or you could assume that it's close to the max operating that the pump shows and say, okay, well, if somebody designed it for that, then they're probably operating that way. I don't know. But yeah, I think collecting that last piece of information and talking to test and balance contractors and understanding, how pumps are going in, how they're being commissioned, and then how they're kind of ultimately being controlled is where there's some opportunity to learn more. And I think what we'll learn there, if I had to hypothesize, is just kind of continuing to corroborate the benefit of easy commissioning, easy balancing, and simplified, optimized control of pump systems. Your design point is never going to be your operating point because there's safety factors there too. So you got safety on safety, and that's just the way it is. You got to account for those valves or elbows that the contractor might put in that you didn't account for when you were designing it. And so the best thing you can do, I think, is continue to do that. Have a safety factor, make sure that you're going to deliver the service the customer wants, but select your pump knowing that's probably more than you need. It's a safety factor, it's insurance, but I'm going to select a pump that I know can be efficient if that's 25% high. So I'm going to select a pump that'll account for that oversizing that I built into my design. And I think the equipment is there now to do that. I think that's a new thing, and that's really going to continue to move the market too. Whether or not that leads to regulation is way above my pay grade. But I do know that in Europe, they are thinking about going to requiring drives across the board for pumps. And, maybe that's a harbinger for what might happen here.
Well, and I mean, AHR 90.1, the latest standard, does require that, at least in the pressure boosting applications. I mean, so we are seeing some of that. I mean, more of a code than a regulation. But I mean, it is why you would install a constant speed pump without a VFD at this point. I
idea.
Don't understand. I mean, I think the VFD is probably cheaper than the triple duty valve, at some of the larger sizes, but that's a whole nother discussion on that. So, as these companies over the last couple of years, and I've been talking with Grundfos specifically on what they've been doing. They've got a couple of the HI certified labs, and they've been testing all of their pumps. And you're seeing it on the other side, seeing all of these submissions coming into the HI database. I mean, what are you seeing in terms of, the number of pumps that are certified? I guess you said about 25% of the market is basically going away. So, how is Grundfos doing in terms of all the pumps that they've been able to get into the database?
Yeah, so Grundfos has a lot of models, especially with their PECO line, which is very specific in terms of their sizing. So Payco probably has the most models certified. So Grundfos as a parent company has the most models certified. The HI rating database has over 7,000 models in it right now. I know Xylem was the first to get their full model line in, so all of Bell and Gossett and Goulds is represented. Taco's got most of their stuff in there now, so everybody is kind of putting their data in now, and I think that's driven a lot by these utility programs that are being introduced, not only in the Northwest. PG&E in California has a utility program based on the energy rating. Excel in Colorado and Minnesota, and a lot of other states are recognizing this as an opportunity. And I think that'll just continue to encourage manufacturers to get their models listed. Yeah.
And they're not going to be able to sell them, right?
Well, the HI database, just to be clear,
it's
HI database is voluntary.
Sure.
They do have to certify with DOE. So.
But, I mean, they're related, right?
They're related. So you might as well.
Right.
You've got the data.
Sure. And what is the best energy rated pump that you've seen submitted?
The best energy rated pump is a Grundfos pump. It's got an energy rating of 70, I believe, or 72. Might be the TPE3.
Yep.
And so they've got the best variable load or integrated pump motor drive combination energy rating, and the best pump motor drive combination average energy rating. So they're really, really doing very well on the integrated products. And then I would say they're more like middle of the pack on the constant load stuff. But that's really not been a focus of theirs. They're really all in on ECM, and I think that's the way the market's going.
Yeah, and this isn't a new, Grundfos didn't react to the regulation. This has been a big push for a long time for Grundfos moving towards that smart pump and integrated solution with the controls. So, and it all goes back to that, the charter of the company, and 5% of the revenue is going back into research and development. And so, I mean, it's cool to see it come back through on the data. Yeah,
it is.
How do you see the PEI and the energy rating evolving over time?
That's an interesting question. Together and separately. So I'm going to talk about the PEI and the energy rating separately.
Fair enough,
I think the energy rating, and I hope, can transform and adapt and expand more quickly than PEI. PEI, being the federally regulated metric, is going to be a little bit slow to incorporate changes. And so I think that it's really great that the HI created the energy rating program that allows us to learn and expand and kind of create new opportunities that maybe PEI will catch up with eventually. So for the energy rating, they have a couple places where they've expanded on DOE's scope already with adding a certificate program that allows a pump and motor that's paired with a drive in the field to have an energy rating that's calculated that represents the energy savings of that drive, even though it's not distributed from the manufacturer. So that's one place they expanded. They also have developed a database for circulators, and that should be launching later in 2020. And that's circulators are not regulated by DOE yet. Manufacturers were in discussions with DOE around regulation, but that regulation was never passed. So HI really picked up where DOE left off and developed a test procedure and metric in this database. And I'm hoping they continue to do that to expand the speed range. I think that'll bring in a lot more of these permanent magnet, synchronous motor technologies that are really efficient. And it's nice that we have a metric that can properly represent their efficiency. And we just need to expand the scope of the speed. I'm hoping they can, consider some of these other pump types that DOE didn't originally regulate. There's a lot of energy savings there. And over time, maybe even move into non-clean water applications. So right now it's limited to clean water pumps or pumps designed to pump mostly clean water. I think there's a big opportunity in wastewater pumps. I know they have to be less efficient because they are designed to pass solids, but there's a lot of wastewater pumps out there, and so there's still opportunities for efficiency without impacting their utility. So I think that's a long game. In the next couple years, if we can just get the permanent magnet stuff covered, and maybe some adjacent pump types, I think that would be a really great step. And then PEI, My hope for PEI is that, the next time DOE considers the rulemaking, which is anyone's guess when that will happen, but I hope that they're able to take a closer look at some of the advancements in motors and controls and, these integrated products. So their regulation, their analysis previously was really, really focused on the pump hydraulic performance. And while the metric acknowledges the efficiency of the other pieces of the system, they were really focused on just improving hydraulic efficiency as a minimum.
Yeah.
So I think the next time around, even just starting to consider improvements in motor technology and controls that are cost effective would be good. Recognizing that, we got to acknowledge cost implications and maybe not everything needs a drive. So I get that it's a long game, but I hope that can become a part of the analysis.
Yeah. It's interesting you brought up the circulators. I mean, I think globally that's half of what Grumpus does.
Yeah,
is
definitely.
So, I mean,
huge market.
When you look at it, you're like, there can't be that much savings. It's a tiny little pump, but there's so many. So, I mean, I could see that being a massive, step towards this whole program having energy savings. So
definitely, and I think the analysis showed when DOE was working on it, the savings from circulators was as big as the savings from commercial and industrial pumps, even though it's a little fractional circulator compared to a 200 horsepower pump. But like you said, they're ubiquitous. They're everywhere.
So many.
And I really would love to see that market transform to fully ECM. There's no reason that it should not be fully ECM. And all the manufacturers, as far as I can tell, are on board with that.
And, down in the South, we don't have even the residential applications for them. But you look in, in Midwest or in the North where you have everybody has boilers and hydronic heating in their houses. I mean, it's even more. You're reaching out beyond the commercial potential there. Yeah,
no, definitely a lot of applications in residential for hydronic heating, and it's, still nascent, but becoming more common to do recirc in new homes. Because people want hot water right away. Water's an issue in some parts of the country, and so they're demanding recirc. California and in parts of the Southwest, I think it's required in new construction homes. Yeah,
that's interesting.
So, it's going to be probably a growing segment.
That's awesome. So if I think there's a lot of confusion around PEI and energy ratings right now, especially this being so fresh for everyone. So if people want to learn more about these regulations or, potential incentives, things like that, what are some good resources for them?
Yeah, that's a good question. I think it is a lot of it's new information, new metric, new standard, new everything. And so it is still very confusing in the marketplace. HI actually has done a really good job of kind of trying to consolidate the information, and they're currently redoing their website that I think will make those resources even more concentrated and available. They have a great background page on DOE's rulemaking and links to like the official documents. But they've organized it and described it in a really good kind of accessible way that DOE is not always excellent at. So I think that's a great resource. And then obviously they have information about their energy rating program on their website. They also have a bunch of videos that they've made that are on YouTube but linked on their website about the energy rating program and the energy rating certificate program. And they have some resources out there, that they're in developing that would be out there for utilities designed to help them create energy programs, pump efficiency programs based on the energy rating database, kind of leverages the knowledge that's out there in the field. So HI, I think, will really probably serve as a clearinghouse for this kind of information. And the other thing I think people can do to find out more about PEI and energy rating, aside from all those great kind of online resources, learning yourself, is just talk to pump distributors and manufacturers. So contact your distributor. That's what I tell a lot of design engineers that I talk to. Is, they should know about this metric and go and ask them, and they can tell you about it. And so I think getting that in-person conversation going is good too. Yeah,
it's funny for a lot of people, this is new over the last couple of days. But like you said, I mean, it's been in the works since 2010. I mean, the manufacturer's been testing for years. So definitely I think they're more in tune with what's going on there.
Yeah.
So, well, that's all we have for this episode today. I really appreciate you coming on.
Yeah, it was my pleasure. It was really fun, Tim. Thanks.
Awesome. Also want to thank y'all for watching, and we look forward to seeing you on the next episode of Building Value.